Hi everybody and welcome to another Scratch tutorial. As you see today we're going to create a 3D maze, which is a super fun game. It is a little bit more complex than other Scratch games that we have created in this channel, but well, I think you will be able to do it. This is a project that other Scratchers and YouTubers have already made, but I wanted to bring it to my channel, adding some improvements that I came up with. So if you are ready, let's get started. First of all, let's begin deleting the cat and adding the maze. So new sprite, let's name it. And I'm gonna create a circular maze. Let's select a 10 pixel width outline and no fill. Pressing shift, you can make a regular circumference. Let's make another one inside. And another one. And let's put some obstacles over here. Well, I know that you might be wondering, and where's the maze here? Hold on. We're gonna convert to bitmap. Now let's take the eraser. The player is gonna start in the center. So let's open a gap here, another one here, and another one here. So the way out is this. All right. Now let's create another level. So we're gonna call it level 1. Now another one, this is gonna be level 2. And this is gonna be more complicated. No fill. Let's make a rectangle. Let's center it. And now let's take this line and I'm gonna make like a grid. You will see the purpose of it later. To make these vertical and horizontal lines that straight, I was pressing shift as well, okay? If not, it would be more complicated, but if you're pressing shift, you see, it's quite easy. All right. So as we've done before, let's convert to bitmap, and we're gonna start here. So let's open, for example, a path here that goes nowhere, and for example the way out could be this. Let's make it complicated. Alright, that's gonna be the way out. And let's make other paths to make it more complicated. That will go nowhere. Let's see. Let's open all this. So the only way to go out is this. Let's open this as well. Over here. Alright, let's open, no, that way, okay. So this is done. So, to begin with, when green flag clicked, when we begin the game, we're going to switch costume to level 1. Let's put it in the center. Okay. And now we're gonna create the player. Well, I haven't told you, but basically we're gonna create the maze in 2D, and after that we will transform that 2D in 3D, which is the complex part of this video. The player is gonna be just a small dot. In this case, let's make it this way, for example. Alright, that's gonna be the player. A little bit bigger if you want, but not much. So the player, when we press green flag, is gonna go there, and that position is this one. And to make it a little bit more difficult, it's going to be pointing in that direction, so that it's not directly seeing the exit. So pointing direction, for example, this one. Alright, so how are we going to move it? Look, forever, and we will use these conditions. If key up arrow pressed, this is gonna move one step. If key down arrow pressed, negative one step, so one step backwards. If right arrow pressed, it's gonna turn like 5 degrees, and if left arrow pressed, we can put here negative 5 degrees, or we take the other block and we put 5. So this way we can move it using the arrow keys, but there is a problem, and the problem is that we can go through the walls, so we have to solve that, and we're gonna solve it in a very easy way. When let's take this. When we move one step, if we are touching the maze, we're gonna move that step back. So if touching maze, we're gonna move negative one step. As this is done automatically, you don't see it moving forward and backwards. You see that it doesn't move. And the same with down arrow. Let's put it here. So when we move back, if we're touching the maze, we will move forward. And with this, as you see, I cannot go through the walls. Okay? So obligatorily, I have to go through the opening. Alright, so this is done. Let's call it player. And now we gotta create something that detects that we have got out the maze, and we have to go to the second level. So I'm gonna put here a sensor. I'm gonna just make a small red line. This red line is not gonna be visible in the 3D maze, but we need to see it now. All right. So when the player is touching this, we're gonna go to level 2. So let's go to player. Well, let's name it. And in player, another condition. If we're touching the sensor and we are in level 1, we have to go to level 2. So let's use an and. If we are touching the sensor and we are in level 1, how do we do it? We have a great block here, this one. Let's take the maze and costume number. So let's take an equal. If costume number is number 1, so if we're touching the sensor and costume number of maze is number 1, so if we're here and we touch the sensor, we're gonna broadcast a message that will be level 1 finished. So when maze receives level 1 finished, it is gonna switch costume to number 2, or you can put next costume as well. So let's go to number 2 to see how it is. So if we're in number 2, player has to start here. So here in player, when I receive level 1 finished, we're gonna go to this position where it is now, which is negative 145, negative 121. Okay, and if you want, we can point in a different direction, for example this one. All right, more the sensor has to go there. All right, so when the sensor starts, the sensor will go here, where it is now, which coincides, as you see, with this position. So when green flag clicked, the sensor is gonna go to this initial position and it's gonna be pointing in the current direction. But let's go to maze. Good. When we're in the second level, the sensor first of all has to rotate 90 degrees. Okay, so when I receive level 1 finished, it's gonna point in this direction and it's gonna go here. So there. Let's see if this works. Well, I'm gonna cheat a little bit. Okay, I'm here. Let's finish this. Now I'm here. Good. And if player is touching sensor when we are in level 2, in this case we said that we're gonna win the game. I'm not gonna make more levels. Obviously you can make more levels in your games. Let's say like victory, for example. Okay, and when we broadcast victory, we can create this. I'm gonna make this sprite, which is victory. Obviously when green flag clicked, this is gonna be hidden. Let's go to the center of the screen, and when this receives victory, it is gonna show. And if you want, we can create a zooming effect this way. Set size to 0. Well, let's set to 0 before showing. And now we're gonna repeat 20 times, change size by 5. So we do that. But there's a problem that we're gonna solve right now. I'm gonna cheat. Look. As you see, it doesn't work, and it doesn't work because as I'm touching the sensor, victory message is being broadcasted repeatedly. So victory is starting this code again and again, but it's not completing it, so it's not growing in size. So that this is not touching the sensor anymore, the sensor should, when I receive victory, we should hide it, and obviously we should show it when green flag clicked. Let's try it again. I'm here, now I complete it, and now it works because it disappears. As I said, this is not going to be visible during the 3D maze, as you saw at the beginning of the video. So now the 2D maze is created, and now we have to transform it into a 3D maze, which is the most complex part of this tutorial. I'm gonna show you the way we're gonna do it. Look, let's go to the beginning. Let me put it like here, for example. I'm gonna take a screenshot. Oh no, haven't done it. Now, and look, the idea is the following. Let's say this player is pointing in, for example, this direction. All right? Is looking at that side. We should see, for example, this angle. Okay? So we have to cover this angle. What does it mean? That we need to know how far this point of the wall is, how far this point of the wall is, this, all this, until this, okay? We should cover all this. How do we do it? We're gonna create another sprite which is gonna be called the distance calculator. And the distance calculator very fast, in less than a second, automatically is gonna move here, 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 and it's gonna calculate how far each point of the wall is, so that we use that information to draw the wall later. So if I'm pointing in this direction, it's gonna turn 50 degrees to the left to start covering this. It's gonna go until it touches the maze. It will write down that distance in a list and will come back. Then it will turn 1 degree. It's gonna move that way. We'll touch this. We'll write down in a list how far this point of the wall is, and will come back until it has covered all this. When we have everything covered, we will have a list with 100 numbers, because we're gonna cover 100 degrees, and we will be able to draw the walls according to that information. So let's begin. As I said, first of all, I'm gonna make my distance calculator, which is basically gonna be a super small dot, this one. Let's name it calculator. Well, when green flag, click not. I'm gonna go to my blocks. I'm gonna make a block, and I'm gonna make a block so that I can use this option, run without screen refresh. So it's like instant. And this is gonna be calculate distance. So what is this block gonna do? Let's define it. First of all, we're gonna create a variable that is gonna be called distance, and we're gonna make also a list distances. So whenever we move and touch a point in the wall, we're going to add that information to this list. So at the beginning, we're going to delete all of distances, and we're going to set distance to 0. We're gonna clean everything. And now we're going to go, this distance calculator has to go to the position where the player is. So it's gonna go to player, and it's going to point in the same direction. So it's going to point in direction. Let's go to sensing. Let's use this amazing block, the one we've used before. Player direction. And after this, it's gonna turn 50 degrees, as we said here. The player is pointing in that direction, but we're gonna be covering an angle of 100 degrees from here, so 50 degrees to the left. So 50 degrees. And now we are ready to begin. We're gonna repeat the following 100 times. And what are we gonna do? I'm gonna put it out here. We're going to move one step and change distance by 1, so that we are memorizing in distance how many steps we're moving. And we're going to repeat this until. So let's take repeat until. We're gonna repeat this until we're touching the maze. Let's take an or, because there are 2 options. We will do this until we're touching the maze. Or let's imagine we are like here, and we are pointing in that direction. We're never going to touch the maze. So we're going to repeat it until we're touching the maze, or we have covered a distance of 400 pixels, for example. So until distance is greater than 400. And we put it here. Once this is finished, once this has finished, once we're touching the maze, or we have covered a distance greater than 400, we're going to add that to distances. We're going to add distance to the list. But this should be out here. And after that, we can go to player again. And we're gonna turn 1 degree. And we're going to set distance to 0. We'll have to remove that information from the variable. And we will repeat this. Okay? So let's see if it works. I'm gonna go here. For example, let's take the distance calculator, and I'm gonna press here to calculate distances. Let's move again. Now, if I calculate distance, the numbers are very low because we're looking at this wall. Probably in this part of the angle, this distance is bigger, and so on. So this is the way it works. But this is something that we have to do again and again. So when do we want to calculate distance? We want it whenever we move. Whenever we move one step forward, one step backwards, or whenever we turn. In every case, we need to calculate new distances because I'm looking at a different place or I have moved from my position. So let's go to player and let's create a different message that is going to be called calculate distance. When am I going to calculate distance? As I said, in this case, okay, when I move backwards, when I turn right, and when I turn left. So now let's go here, and whenever I receive calculate distance, I have to calculate distance. So as you see, as I'm moving, these distances are changing. So I have it. I have created a method that allows me to calculate distances instantly. And what do I have to do now? Now I have to transform those distances into the 3D maze, which looks very complicated, but it's not that complicated. It is feasible. So let's go. I need another sprite which is going to draw. That sprite could be whatever, because it's going to be hidden. You can take the apple, for example. So let's hide the apple. And we're gonna go to my blocks and create a block that's gonna be draw, and obviously run without screen refresh. That is the key of this project. Okay, so draw. What is draw? Let's see. I'm gonna go to paint and I'm gonna show you what draw is. Oops. Look, let's say I am close to the wall. If I am close to the wall, draw is going to draw, all right, big lines that will represent the wall. These lines will be close together, okay? There won't be any separation between them. If the distance is far away, if the distance is big, the wall is far, so the lines, the vertical lines, will be smaller. So first of all, let's define draw. I need to create another variable which is going to be counter. I'll show you later what this is for. When we draw, well, we need to add the pen tool. When we draw, we're gonna start with pen up. We're going to go to this position. We're gonna be drawing from left to right. As this is instant, it doesn't matter if you go from right to left, but we have to make a decision. So let's go to -240 and y0. So this position. We're going to draw lines upwards and downwards. So let's begin setting the counter to 0. And here we're gonna change counter by 1. So this is gonna be the element of the list that we're going to take. So when we're here, I want to draw the first element in the list. So counter is gonna be 1. I'm gonna put the pen down and I'm going to change y by, and now important, if this number is big, it means the wall is far. So the line should be small. So how do I transform a big number into a small number and the other way around? If this number is small, 21, it means the wall is close to us, so the wall has to be big. In that case, we need to use a division. And this is something I have already calculated. We're going to divide 1500 into this element of the list. So, item counter of distances. So this means if this item in distances is, for example, 100, that means the wall is far. 1500 divided into 100 is just 15. So the line will be small. Why? Because the wall is far. The wall is 100 pixels away. However, if this element of distances is, let's say, 1, so I am almost touching the wall, this number divided into 1 is 1500. So this line will go out of the screen, all right? Because I am like touching the wall. I'm in front of it. After this, after drawing from the center, well, from this part upwards, I'm gonna go to the center again, to y0. So set y to 0, and I'm gonna repeat this, but this time going downwards. So let's make it negative. After this, pen up. And now we're gonna move right to draw the next line. So change x by, I'm gonna change x by 5. So if I'm going to change x by 5, the width of these lines should be 5. So that's something I'm gonna do at the very beginning. Pen size, set pen size to 5. And we can also set pen color to some kind of brown. So how many times I'm gonna repeat this? 100, because 100 times 5 will cover the width of the whole screen, which is 480, okay? So let's repeat it 100 times. So draw is defined, and now the question, when are we going to draw? We are going to draw whenever we calculate distances. So let's go to the distance calculator, and after finishing it, this is gonna broadcast a message which will be draw, and our apple, which is our painter, when it receives draw, first of all it's gonna erase all. Basically, because if we have moved, we're gonna see something different. So the previous maze that we were seeing is not valid. Obviously, when it erases and draws super fast, you're not going to see the screen blank, okay? And let's see if it actually works. It does, okay? As you see, it works, guys. I'm moving around the maze. So as I'm moving, it is receiving new information, it is erasing all and drawing new perspectives, okay, new views of this maze. So some problems that we need to solve. For example, if I'm here, as you see, I'm pointing at the exit, but I see this tiny wall. Why? Because that is this number, but it still draws a tiny line. So we can tell the apple not to draw this line when this distance is greater than 400. So it is quite simple. Pen down only if this distance is lower than 400. So let's take a condition. Only the pen down is going to be inside that condition. Only pen down, so only draw if distance is lower than let's say 400. Yeah, it's not distance, it's this item. Now if I move, as you see, we don't see that line because this is empty. Okay, this is the exit of this maze. More things that we could do. We could, for example, change the brightness of these lines according to their distance. So that's here in the Apple as well. Let's set pen brightness to something like this, okay, depending on the distance, but let's put 600. And look, as you see, it creates a realistic effect, a more realistic effect. Okay, the closer I am to the walls, the brighter they are, and the further they are, the darker they are. Okay, so that's another thing that we can do. We can also color the ground and the sky. That's quite simple. Let's just go to backdrops, and let's say this could be a combination of blues, and the ground could be grass, for example. Let's put it here. So let's take some greens. Okay, and now let's hide all this. Distances, distance, counter, and important, you cannot hide this because if you hide it, it doesn't work. So what we have to do is add a ghost effect. We're gonna set ghost effect to 100, and we have to pass this to the player. We have to pass this to the sensor, set ghost effect to 100, and also to the distance calculator. And now it works, okay? And that's all, guys. As you see, it's a very fun game that you can share with your family and your friends to play. You can make as many levels as you want. I've only made 2 because this is just an example, but you can make as many as you want. The complex part is the coding, but creating more and more levels, it's quite simple. So I hope you enjoyed it, and see you next time. Bye bye.